All right, so this is supplement to what we did in class in 13-14 with factoring. If you want this organizer, I do have copies. You can do the notes on there, or you can just take them in your spiral if that's easier for you. So first thing is just we're doing factoring quadratics, and what this means is you're going to see something with an exponent, and it's going to be a squared. It's going to be a 2. We'll do more stuff with quadratics later, and you'll see why. But anytime you see that, we're going to be factoring if it asks you to solve something along those lines. So the first step we're going to start with is called greatest common factor, and this is something you're always going to look for first because it's either going to tell you need to continue factoring or basically you can stop and you've done the hard part. If you don't take that greatest common factor out, it can really mess you up. You can get yourself into steps you don't need to be in, stuff along those lines. So what the greatest common factor is a number or a variable that divides into all terms. So what you're going to do, of course, is look for that number or that variable. Sometimes it's both though, and it has to go into every single term that you have. So what I'm giving you first is 4x plus 16. So this has two terms. The first one is 4x, the second is 16. So like I said, we're looking for a number and or a variable that divides all terms. So when I look at the numbers, I'm going to look at 4 and at 16. I need to ask myself, what is the biggest number that goes into both of those? So I can divide them both by 1, that doesn't count. I can divide them both by 2, but I can go even further and I can divide both by 4. Now I have the number that goes into both. I'm going to look to see if they both have variables. When I look, I see that 4x does have an x, but there's nothing with the 16. So that means I cannot divide both of them by a variable. In this case, I'm just going to divide both by the number. So when I go and I divide 4x by 4, so this first step right here, the 4's cancel out and I'm just left with x plus, I do the same thing with the second term, 16 divided by 4, and that leaves me with 4. So when I take the greatest common factor out of here, it's x plus 4 left over. But this isn't my answer. This is not my factored form. I have to take whatever I just divided by, so that was 4. I'm going to put it outside of parentheses. And inside the parentheses, you put whatever was the leftovers. So I was left with x plus 4, so that's what goes into parentheses. Now in this case right here, we would call this our factored form. I can't pull anything else out, and I have that 4 on the outside, so you leave it just like that. Now the next example is 2x squared minus 4x. So again, I'm going to check first for a number. I see that I can divide both of these by 2. So I've got that taken care of. I've dealt with my numbers. Now I need to look at the letters. When I look at the first term, it's x squared. When I look at the second term, it's x. You can only take out the smallest one though. So I'm going to take or divide by an x in each of these. Now when I do that on the left right here, 2x squared divided by 2x. If I wanted to write that down, I have 2 times x over 2 times x. And I start canceling stuff out. So I have the 2's gone, I have the x gone, and all I'm left with is an x. So 2x squared divided by 2x leaves me with just x minus, I could do the same thing for 4x divided by 2x. What happens is my x's go away, and I have the numbers 4 divided by 2, which leaves me with 2. But remember, that's not our factored form, so we need to get our factored form. So I take whatever I divided by, which was 2x, that goes outside of the parentheses, and inside the parentheses is whatever you were left with, which happens to be this x minus 2. So inside goes x minus 2. So if you're dealing with greatest common factor, this would be your factored form. Remember, you could have multiple variables, you could have 4, 5, 6 terms. This is just the basics behind it. So there's going to be about 4 examples that pop up that have you practice greatest common factor. Make sure you work these on a separate sheet of paper, on the back of that organizer. It's really good practice and it's really good to have in the future. So I'm asking you for all these to factor, and your first one is 16p to the 4th plus 4p cubed. So in this one, I asked you to factor by greatest common factor, and it's 16p to the 4th plus 4p cubed. So remember, you check for numbers first. So I'm going to divide both of them by the greatest number that goes into them, and it does happen to be 4. So I'm going to divide both of these by 4. When I look at the variable, I have p cubed and p to the 4th. So that means I can pull a variable out. I pull the smallest amount out, so I'm going to divide by p cubed on both. So I have 16p to the 4th divided by p cubed. I first do 16 divided by 4, which gives me 4. And then p to the 4th divided by p cubed means I'm taking 3 of those p's out, and I'm just left with 1p plus 4p cubed divided by 4p cubed. Anything divided by itself just leaves you with 1. So that's what I'm left with, but my factored form, remember, you have to put whatever you divided by, so 4p cubed, and then whatever was left over, plus. So I end up with 4p cubed times 4p plus 1. Number 2 is 11x to the 7th plus 13y to the 4th plus 8. Now number 2 reads 11x to the 7th plus 13y to the 4th plus 8. So I'm first going to look at the numbers. Is there anything I can divide 11, 13, and 8 by? And I can't, so I can't divide by number. So now I'm going to look for the variables or the letters. I have x to the 7th, y to the 4th, and 8 doesn't have any variables or letters. This is a situation where you cannot take anything out. You actually can't factor this, so this is something that we call prime. You can't factor anything out, can't do anything with it. So your answer would just be the same, 11x to the 7th plus 13y to the 4th plus 8. Number 3 is 10n cubed minus 9n squared plus n. Number 3, I'm going to check for the numbers first. I have 10, 9, and there's nothing here, so remember that's a 1. I can't divide all 3 of those numbers by the same thing, so I'm going to check for the letters now. I have n cubed, n squared, and n. My smallest variable that I have is n, so I'm going to divide everything by 1n. When I do that with the first piece, 10n cubed, I still have the number 10, but n cubed divided by n, I take out one of those n's, and I'm left with n squared. Minus, I didn't divide the 9 by anything. I have n squared divided by n, so I take out one n, and I'm left with one n. Plus, remember, anything divided by itself just leaves you with 1. So I put all that in parentheses because that's what I'm left with. And remember, on the very front on the outside, you put whatever you divided by. We divided by n. And the last one is 20 minus 35n squared minus 20n cubed. So number 4, again, we're going to factor completely by checking for the GCF, that grades common factor first. When I look at the numbers, I have 20, 35, and 20 again. So I know I can divide each of these by 5. Now when I look at the letters, I have no letter with the 20, so that automatically tells me I can't take a variable out. I can't take a letter out, so I'm just going to stop there. So I'm taking out 5 from everything. When I do that in the first piece, 20 divided by 5 leaves me with 4, minus 35 divided by 5 leaves me with 7, and I still have the letter, so 7n squared, minus, again, 20 divided by 5 does give me 4, and you have the letter as well, so n cubed. So my factored form of number 4 would be 5 times 4 minus 7n squared minus 4n cubed. You can rewrite this so that the highest exponent is first, so you can leave it like that, or you can rewrite it as negative 4n cubed minus 7n squared plus 4. Now back to the notes. The next thing I'm going to hit is called difference of squares. This is a special type of factoring. What we're going to do is show you some factoring in a little bit with these steps to it, and it works with all the other kinds. There's 2 of them. The first one's difference of squares. It's kind of like a shortcut. So what the difference of squares is, how to recognize it, it's 2 terms that have perfect square roots and they're separated by a minus sign. So if you see 2 terms that you can take the square root of each of them and there's a minus sign in between them, you can use this trick. So what it looks like is a squared minus b squared, and what you do is you take the square root of a and put it at the front of each parentheses. You take the square root of b, put it at the end of each parentheses, and in one of them you put a plus sign, and the other you put a minus sign. So an example of that looks like this, 49x squared minus 1. So the first thing I look for, is there two terms? Yes, there is. I now need to see if they each have perfect square roots. What that means is I need a number times itself that multiplies to give me 49. And I know that number is 7. Now I need a variable multiplied by itself to give me x squared. So the square root of 49 was 7. The square root of x squared is x. So that's the first term. The second term, I need to see if it also has a perfect square root. So I need to ask myself, what is the square root of 1? And it does have to be perfect, and it's 1. So I have two terms. They both have square roots, and the last thing I check for is to see if they're separated by a minus sign, which they are here. So I can use the shortcut of the difference of squares, and I told you, you have two sets of parentheses. You put the square root of a squared, which was the first term, at the beginning of each parentheses. So I'm going to put 7x in front, and then I put the square root of b squared at the back of each parentheses. Now, the only thing that separates the two is one of them gets a plus sign and the other gets a minus sign. This would be the factored form of 49x squared minus 1. So again, I'm going to have two examples this time for you to practice with difference of squares, and I'm asking you to factor them. So the first example is x squared minus 4. Alright, so we're going to start in with the difference of squares examples. So remember, the first thing you look for is if there's two terms that you can take the square root of. So I need to ask myself, what is the square root of x squared? What times itself will give me x squared? And that does happen to be x. I check the second term. Is there a perfect square of 4? What times itself will give me 4? And that happens to be 2. So then when I set it up in my parentheses, remember you have two parentheses. In the front, you put the a term, so I'm going to put x and x. At the back, you put the b term, so 2 and 2. And the only thing that's different is one of them has a plus sign, one has a minus sign. So this is the factored form of x squared minus 4. And example 2 is 16x squared minus 25. So number 2 is 16x squared minus 25. I need to ask myself if I can take the square root of both of these. There is a square root of 16, which is 4, and we already know the square root of x squared is x. So the first term is good. The second term, the square root of 25, if you don't know, is 5. So I do have two terms that I can have a perfect square root of, and they're separated by a minus sign, so I can do my difference of squares here. So in the front goes your a term, which is 4x. In the back goes the b term, which is 5. And again, in between them, one of them has a plus sign, one has a minus sign. So the factored form of 16x squared minus 25 is 4x plus 5 times 4x minus 5. Now I told you how difference of squares was like a shortcut in factoring. Perfect squares is that second shortcut with factoring. Now this one is a little bit more difficult to just recognize off the top of your head, especially if you haven't done factoring in a while, so it's okay if you don't get it. This one has three terms in it though, and it looks like a squared plus 2ab plus b squared. We're using a and b in the factored form, so you would take the square root of the a squared, the square root of the b squared, and what you plug it into is two parentheses that look exactly alike. It's a plus b times a plus b, so you can write it this way, or you can also write it as a plus b squared because they're being multiplied and they're the exact same thing, just like x times x is x squared. So the example I'm going to give you here is x squared plus 6x plus 9. So I am going to label it kind of like the general formula I gave you. In this situation, x squared is my a squared, plus 6x is my 2ab, and 9 happens to be b squared. So I'm just going to show you how you check to see if it works. Like I said, if you don't understand this, that's fine. We're about to go to another factoring that'll also work with perfect squares. So a squared is equal to x squared. So that means a, if I wanted to find it, I have to take the square root of x squared, which would give me x. X times x gives you x squared. I'm not going to worry about the 6x because we're going to check that part in a minute. But I am going to look for b. So I have to take the square root of 9. So what number times itself gives you 9? And it's 3. Now that middle part is 2ab. So 2 times a times b. So we're going to check that right now. So 2 times a, which I just found out was x, times b, which I found out was 3. I then have 2x times 3, and finally 6x. It does check out with that middle term. I got 6x here, 6x there. I know now that I can use perfect squares to factor this. So my factored form is in the parentheses a plus b. So my a value, remember we found that as x, so I'm going to put that at the beginning of each parentheses. You have your plus sign in both of them, and it's plus my b, which I found to be 3. So you can write it in factored form as x plus 3 times x plus 3, or you can also write it as x plus 3 and then just have it squared. So I'm just asking you to try it out, do one example. The example is x squared plus 8x plus 16. Again, make sure you are factoring this completely. So remember, this is that perfect square example where if you don't get it, it's totally fine. You want to look at your first term and your last term. I want to take the square root of both of those. So the square root of x squared is x. The square root of 16 is 4. Now I need to see if I double this number, will it give me the middle number? So 4 times 2 does give me 8, so I can use a perfect square here. So these ones, your parentheses look exactly the same. I take my a term, which is x, and put it in the front, my b term in the back, and both of them have the same sign as that middle number, so I put plus signs. So you can write it as x plus 4 times x plus 4, or remember, you can also write it as x plus 4 squared. And the last one that I am going to hit in detail today is to just get that extra practice in. These are trinomials with a equals 1. What that looks like is x squared plus bx plus c. There's going to be no number in front of the x squared because remember, when there's no number there, it means 1. So this is what they'll look like. There will be numbers for b and numbers for c, but if you see just x squared by itself, then you can follow these steps. So the first thing you're going to do is look at the last term, which is c, and then you're going to add or subtract factors of that term c to get the middle term b. So the first example I have is x squared minus 7x minus 18. So I told you to look at that last term c, which is negative 18. So I'm going to write it out here because the next thing that I'm going to do is start listing off its factors. And factors are two numbers that multiply to give you that third number. So I need numbers that multiply together to give me 18. So I have 1 and 18. I know 2 times 9 and 3 times 6. 4 doesn't go into it, 5 doesn't go into it, and 6 times 3 is already there. It starts to repeat, so that's how you know you're done. Now we have to figure out what signs are going to go on these. So if you notice here, this is a negative 18. So that tells me that one of the numbers is going to be positive and one of the numbers is going to be negative. Now the way you decide that is by this middle term right here. So this middle term will tell you which of your numbers is negative, which of the bigger numbers is negative. So it's a negative 7x, so that tells me on all the bigger numbers, I'm going to put a negative sign. So negative 18, negative 9, negative 6. Now I need these numbers to add up to that middle term, which is negative 7. So 1 minus 18, that gives me negative 17, so I know that's not going to work. 2 minus 9, that does give me negative 7, so it's possible. So you need to make sure you check the last one. 3 minus 6 gives me negative 3, so that's not the one that I need either. Now, because this is trinomials with a equals 1, you're basically done. You have two parentheses. You put x in front of each of them, and then you put the numbers we just found, so 2 and negative 9, with their sign. 2 is positive, so it's going to be plus 2, and that negative 9 is negative, of course, so it'll be minus 9. So x squared minus 7x minus 18, the factored form is x plus 2 times x minus 9. Now I'm going to do another example, x squared minus 5x plus 6. So again, we look at that last number, which is positive 6. I'm going to list out my factors, 1 and 6, 2 and 3, and that's it. I now have to look at this sign up here. I told you if it's a minus sign, the signs of the numbers are different. So if it's a plus sign, they're going to be the same. And again, this middle term tells you what they're going to be. So since they're going to be the same and it's a minus 5x, both numbers get a negative or a minus sign. I go ahead and do the first operation, -1 minus 6. That gives me -7. That is not -5. So I cancel that out, cross it out. The second one is -2 minus 3. That does equal -5. So that's what I'm going to use. Again, we set up our two parentheses. I put x in front of both of them. And I put the numbers with the signs in the other part. So x minus 2 and x minus 3. And that's your factored form. So your first example to do is n squared plus 10n plus 16. Alright, so these last examples, these are the ones where a is equal to 1, the number in front of the x squared or the squared term in the front is not there, so it's assumed to be 1. So remember for these, you look at that last number, so 16, and we start listing out the factors. I have 1 and 16, 2 and 8, 3 doesn't go into it, and then you have 4 and 4. Remember that 16 is positive, so I know that the signs are going to be the same. And this middle term right here tells me what they're going to be, and they're all going to be positive. So I'm going to put plus signs on every single one of them so we remember. Now I'm going to perform that operation. 1 plus 16, that gives me 17. I need 10 in the middle, so that's not it. 2 plus 8 does give me 10, so that's possible. And the last one, 4 plus 4, gives me 8, so I can't use that one either. I have my numbers, so I can set up my parentheses. Remember, in the front, you put your letter, the square root, so n and n. And then you put your factors with their signs. So I have n plus 2 and n plus 8. This is my factored form of number 1. The second one is b squared minus 9b plus 14. And number 2, we follow the same steps. We look at that last number, so plus 14, and I'm going to start listing my factors. I have 1 and 14, and then 2 and 7, and that's it. Now, I know that the numbers are going to have the same sign because of that positive, and the middle term, remember, tells you what the sign will be. So both numbers are going to be negative. Now I do -1 minus 14. That gives me -15, but I'm looking for -9, so that's not it. And the last one, -2 minus 7, does give me -9, so I'm good to go there. I set up my two parentheses. In front of each of them, I put b, and then now I'm going to put each of these numbers with their sign. So I put a -2, a -7, and now that trinomial is factored. Number 3 is k squared minus 4k minus 60. Number 3, the number I have is -60, so it's a little bit larger. So we list out our factors, 1 and 60, 2, 30, 3, 20, 4 and 15, 5 and 12, 6 and 10. 7 doesn't go into it, 8 doesn't go into it, 9 doesn't, and at 10 we start repeating. So here we have to be careful because it's a -60, so that means that my signs are going to be the opposite. I'm going to have one positive, one negative, and then this middle term, remember, tells you what the bigger numbers will have. So all of these bigger numbers are going to have negatives with them. So I'm going to go ahead and put the negatives on them. And I'm just going to start doing all this. 1 minus 60 is -59, so that's not it. 2 minus 30 is -28. 3 minus 20, -17. 4 minus 15, -11. 5 minus 12 is -7. And finally, 6 minus 10 is -4, which is what I'm looking for. So I have my set of numbers that I need. I set up my parentheses like I have been. K goes in the front, and then I put the numbers with their signs. So I have a +6 plus 6 and a -10 or -10, and here's your factored form. And then the last one, m squared plus m minus 6. And the last example we have, number 4, is m squared plus m minus 6. So same as usual, -6 goes on the end. 1 and 6 are my factors, and 2 and 3. Because it's a minus sign, I know that I'm going to have one positive, one negative. Now in the middle though, I have a plus, a positive. So my bigger numbers are going to be positive. My smaller ones will be the negative numbers. So now -1 plus 6 is 5. I'm looking for a +1. That's not it. -2 plus 3 does give me +1 though. So I have my factors. I set up my parentheses, put m in the beginning of each one. I put -2 in one of them and +3 in the other. And I now have number 4 factored.